Hello there, how are you? I have a new project, so let me first present you a problem, right? I have an older car which basically has Bluetooth, but it's only voice connection, right? It cannot do music streaming in any capacity. There is a USB port which I can use for USB sticks with MP3 files or maybe Android phone in a file transferish kind of a mode with MP3 files, and also I can plug in an iPhone or an iPod in iPod mode, but Apple has this weird agenda that they want to lock you in, so the only way you can stream any kind of music is via Apple, what it's called, Apple Music, right? It cannot be Spotify or Tidal or whatever. It must be Apple Music, and you must continuously be paying for the subscription to Apple Music in order for the iPod emulation to be functional. And this is the only way that my car can accept the whatever Apple device, right? If you subscribe, if I subscribe to Spotify, for example, it just doesn't work over the iPhone. It must be Apple Music. So, of course, I am not really a fan of Apple's lock-in mechanisms, and I try to avoid all of the Apple crap in any way that I can, unless I really, really have to. And in this case, I really don't have to. I have been researching my problem and trying all kinds of complex things like Volumio on Raspberry Pi and Mood music player and all these things like support AirPlay and such stuff, but it's very complex and finicky and doesn't work very well. And recently I tried Spotify, and actually I have discovered a really simple solution. It's called Spotify D, like Spotify daemon. Let me show it to you. I have prepared the Raspberry Pi 3A Plus for this case, and I think it's around $25 or something like that. It's really cheap and light, and it uses very little power, so it's really convenient, and it of course has an audio output. If you need audio output, which in my case I do, you have two most practical choices. These are Raspberry Pi 3 or 4. There are some other options where you can buy a separate hat for the like a sound card to get the better quality sound if you're a hi-fi person, audiophile or something. But for the most basic setup, Raspberry Pi sound card or DAC if you want is perfectly good for most of your use cases. So let me show you how this works. So first of all, you are going to want to download Raspberry Pi Imager and prepare an SD card, micro SD card for booting the system, right? So this is where you are going to pick your device, for example, Raspberry Pi 3 or 4, which one you have prepared. Then you are going to have to choose the operating system. Go to the Raspberry Pi operating system other, and then choose the Raspberry Pi operating system Lite. This is without the desktop because you're probably not going to need it. At least I did not need it in my use case. And you're going to need to pick the 32-bit version, although the Raspberry Pi both 3 and 4 are 64 bits, but the binary of Spotify D that we are going to download from GitHub is, as far as I know, 32-bit only. So you're going to need this version of the operating system. Okay, flash it to your preferred storage. In my case, this is a 128 gigs SD card. Go next, and this is the important part. You need to go to edit settings. You need to preferably use the SSH service if you're going to tinker remotely. You are going to want to set your username and password, And the important part is to use your hotspot for your phone. And the reason for this is because the way I have envisioned this solution is that I'm going to use this in my car, right? And the Raspberry Pi in my car needs to use the internet in order to stream Spotify. So the workflow that I have in my head is that I'm going to start my car, Raspberry Pi is going to boot up, it is going to connect to the hotspot of my phone, and then I'm going to use the Spotify application on my phone to remote control the Spotify daemon on the Raspberry Pi connected to my car and output via audio cable to the audio in of my car. So all this sounds a little bit complex, but it's actually really simple in the end, and I'm going to show you and demonstrate to you after this video is finished. So the important part is that you're going to need to have to give the Raspberry Pi a way to connect to the internet. If you have any other way to connect to the internet, like maybe your car has a permanent internet connection or something of that kind, feel free to use whatever internet connection. But the important part is that your phone, which you're going to use as a remote control, and your Raspberry Pi are going to have to be on the same network while you're driving. In my case, this is just a hotspot, right? Just save it, click yes, and flash all of this to your SD card. When you're done flashing, you can close this, you can transfer your SD card to your Raspberry Pi. Don't move anything to your car yet, you have a lot more to set up. So let's go to my Raspberry Pi, right? The first time when you boot up the freshly prepared microSD card with Raspbian OS on your Raspberry Pi, it is going to take a while for the first boot, for the file system expansion, for a second boot, etc. It will take about 5 minutes, maybe more, depending on your card speed. Speaking of speed, you can use whichever SD card you want. Faster card will give you a slightly faster boot times, slower card, whatever. And I am using actually a 4 gig card in my actual setup for the car. Recently, when I mentioned 128 gigs, this is just for demonstration purposes, but actually I'm using a really cheap, almost gratis 4 gigs card. Once you're finished booting up everything, you're going to end up in the console of your Raspberry Pi. The way I have connected this is I have used the HDMI output from the Raspberry Pi to the capture card of my PC where I am presenting this, and I have this keyboard connected directly to the Raspberry Pi so I can control it, and that's pretty much it for now. So the first thing you're going to want to do is let me just switch quickly back to the to my desktop where I'm going to show you what we are installing. So this is the software that we are installing. It's called Spotify D. You will find the releases here. The latest one as of making this video is 0.35. 0.4 is also announced, so the moment when you're going to look at this video, there might be a newer version with some newer config files, right? So if some of my config files don't work and you're using a newer version than 0.3.5, then please check the documentation if something has changed in the meantime. So after you have installed the 32-bit Raspberry Pi operating system, you are going to need to download Spotify Linux ARM HF default, which is right now 7.55 megabytes. You can use the wget on Raspberry Pi to fetch it directly to your Raspberry Pi. And once you are there, it is going to look like this. I have actually downloaded the full version, but I don't think there is any difference in this case. with tar command Spotify, you're going to unarchive this archive, and the only thing that you're going to get is this Spotify D file. So in order to check if Spotify D is working, you're just going to have to execute it like this. And what is going to happen, the Spotify daemon is automatically going to start, and you will already be able to test your connection with the Spotify application on your smartphone and the Spotify daemon. But while we are preparing all of this, let's go to the .config Spotify D. If you don't already have this directory, you're going to have to make it. And you're going to have to make a file called spotifyd.conf. And what you're going to put inside that file is just copy paste from this configuration. If you are unable to copy paste or type from my screen, just pause it and transfer everything. You can also go to the documentation and go to installing on Raspberry Pi. This is going to tell you how to unpack the file. Default configuration section, go to configuration section, and you're going to find a copy button which will copy the whole of this file here. However, I have already removed a lot of unnecessary stuff from this file, so you just maybe want to see what have I done on my end. So here, the first thing is username and password under global configuration, and in my opinion this is totally not required, so I have just completely skipped this, because when the Spotify application on your phone is giving command to your Raspberry Pi Spotify D, it will automatically log you in, so this is unnecessary. For backend, just use ALSA under quotation marks. For the device, most likely you're going to use the hardware, but you can check with the command apply-l. Let me just exit this file shortly. Apply-l, and here is you can see all of the audio devices that you can use, but just trust me, bro, use the hardware command on the Raspberry Pi. For mixer, you can use PCM. For volume control, just type ALSA. Device name is the name of the Spotify remote device that you're going to see on your phone application on the Spotify when you will search for other Spotify devices on your local network. So basically you can type the name of your car. This is where I typed the name of my car. For the bitrate, feel free to choose any of these three, so 96, 160 and 320. It's up to you to choose. Cache path. Okay, so this part is important. If you are going to use the cache, then you will going to need to define the cache directory. If you don't want to use the cache, then you can uncomment the no audio cache line, and what this will do is that there will be no cache of your music, and the amount of cache that you want to use is max cache size. So if you put like, let me show you how many of these are. So if you put 9 zeros and 1, this is going to be 1 gigabyte. If you remove 1 zero, this is going to be 100 megabytes. So in my case, this is 100 megabytes, and the reason for that I'm going to tell you in a moment. What I'm going to do in the end with this configuration is I'm going to use the overlay file system on my Raspberry Pi, and my Raspberry Pi only has half a gigabyte of RAM. So if you use a more richer version of Raspberry Pi 4 with a couple of gigabytes of memory, then you can feel free to use max cache size of 1 gigabyte or how much you prefer. If you're going to use the overlay file system, if you're not going to use the overlay file system, then you can use the cache size according to the free space on your SD card. And why I'm going to use the overlay file system, what the overlay file system is, actually, that is a better question. The overlay file system is basically a function integrated into the Raspberry Pi operating system that you can enable. And when you do that, when you boot up from the SD card, it will automatically use RAM instead of your SD card for all future writes. So what this means is that while the Raspberry Pi is working, whatever is being changed on the file system, nothing is going to be written to the SD card. And why this is good is because the way that I'm planning to use my Raspberry Pi in my car is that when I finish my driving, I'm just going to turn off my car and take my key, and this will kill the power in Raspberry Pi. And killing power in Raspberry Pi multiple times in a row might result in corruption of your SD card eventually. Maybe yes, maybe not, but I don't want to risk it. So what I'm going to do is simply not allow it to ever write anything. And the way overlay file system works is it fills up the RAM. So if you tell it to write to the cache path of temporary or whatever folder, it is not going to be a folder on your storage card, but actually in the RAM. And on reboot, this will be cleared. But you have to be careful on how big you're going to make this cache according to how much RAM you have. So when we finish setting up the whole system, it will only be using like 70 megabytes of RAM without the files, without the overlay file system, and overlay file system will use some more, and we will have like roughly 100 plus megs of usable like temporary file system storage in my RAM. So as I said, if you have more RAM, feel free to experiment with this. If you're not going to use the overlay file system, then feel free to use however much storage you want, but then you might want to somehow take care of the Raspberry Pi safely shutting down before you power off your car. Sorry for talking so much, but I just wanted to make sure that all of you understand the consequences behind making some of these decisions. Volume normalization, this is to make the songs like of equal volume. Normalization pre-gain, you can keep this on minus 10 decibels. Initial volume, you can just turn it all the way up and control it on your car radio. Autoplay through, this is to continue playing similar songs after your playlist has finished. So you can disable this or not, it's up to you. One other thing is important regarding cache. If you don't use cache, this is also an option, so you don't write to your card or to overlay file system, but not having cache will result in slight pause when you click next song, because the next song needs to buffer. If you use cache, then the next song is going to buffer up front. So no cache equals like roughly 1 or 2 seconds of pause between songs when you click next. And if you have cache, then when you click next, it goes to the next song immediately. So this is so having some cache is definitely preferred. Once you're done with setting up this file, you're going to need to make sure that this auto runs on every reboot. So go back to the config folder. You're going to have to make the systemd folder. Just make it, and when you go to systemd folder, you're going to make a user folder. Go to that one, and in the user folder, you're going to have to make spotifyd.service. I have already made it. You can also find the same instructions on the GitHub page that I have shown you earlier. But basically what you need to do is in unit, type any kind of description that you prefer. This is only related to boot. What this systemd script wants is it wants sound.target, it wants network-online.target, and also it will start after these two have already been running. In service, you need to type exec start and just type the path to where your binary has been downloaded. You need to type no daemon, so it doesn't go to the background. Restart always. The restart seconds by default it's 12. I find it a pretty usable value, so I don't have the need to change it. Install wanted by default target. This is related to systemd service. Keep up with me, we're almost finished. So now type systemctl -user start spotifyd.service and press enter, and this is going to start your service. So what you can do now, you can go to the to your phone, right? And when you find music, there is a button on bottom left of on the Spotify. It's hard to see, but it will show you the list of the devices that Spotify has. Press on your car name, and basically, I'm not sure if we can focus this, but yeah, we can. So now it says it's playing on Mariva. This is the name of my car. Now that we have tested that everything is fully functional, we need to type some more commands in order for all of this to automatically start on system boot, right? So what you are going to want to do next is sudo login enable linger and your username. So what this did is the word linger, right? It gives you the user that we have defined here. It gives this user a possibility to run services while it's not logged in, right? So you don't need to log in order for the services of this user to be available, let's say, in background. The next command that you need to do is systemctl user, but not start, but enable spotifyd service. Once we did all that, we are completely ready to reboot our system and see if everything is running completely automatically. So let's just type sudo reboot, and we should be good to go after the system boots up. Okay, the system has successfully booted back up, and notice the IP address of my Raspberry Pi. This means that it is already connected to the hotspot of my phone. And when I press this button on the Spotify application, you can already see that it is finding my daemon running, so I can already play my music. So one final step is enabling the overlay file system, which is completely optional and up to you, and you really don't need to do that. But if you're going to be unplugging the power from Raspberry Pi on your drive finish, then you might want to use this. If you're going to use this whole configuration in order to have like a home player that is a headless Raspberry Pi with a speaker, then you might want to skip the overlay file system and just manually shut it down. So there are multiple options, right? This is not strictly a solution for the car. You can plug in this Raspberry Pi to whatever external audio speaker you want. Let's log in. Okay, sudo raspi config. Let's go to the performance option, overlay file system. Would you like to overlay file system to be enabled? Yes. And you're going to give it a moment. There you have it. The overlay file system is enabled. There will be another question. Would you like the boot partition to be write protected? Say yes to this one as well. The boot partition is now read-only. Okay. And we can finish with the Raspberry config. Would you like to reboot now? Of course, yes, because we need to apply the whole thing. One final warning while this is rebooting, do not enable overlay file system before you are completely satisfied with the way that the whole thing is functioning completely automatically. Because once you enable the overlay file system, you're not going to be able to change anything anymore. Unless, of course, you revert the read-only stuff. You're going to go to the Raspberry config again and just disable the whole thing, reboot again, and then you're going to be able to change stuff, update the operating system, etc. Okay, we have now booted up into the overlay file system, and let's start my Spotify. Spotify is running, and there we have it. My device is already listed, so it means that everything is functioning properly. And let's just check the RAM usage. There we go. We are currently using 60 megs of RAM, which is the same as before using the overlay file system, but once you start writing to it, there will be more usage. Let me just give you a small proof that overlay file system is working. Like, we are now in my home folder, home dart, and let's touch the file called, I don't know, example, touch example. We have now made the file called example, got something into the example file. I meant echo, sorry about that. Cut example. So there is something in my example file. And now we are going to sudo reboot, and after reboot there will be no such file, because the whole thing is in the overlay file system, which is inside the RAM. There we go, we are now rebooted. Dart and my password, and there is no example file in my home folder. So the whole thing is working perfectly and as expected. Okay, let's go to my car and let me show you how the whole thing works from my user perspective. Okay, we are in my car now, and here's the super easy part. So for the audio out from your Raspberry Pi, you're going to have to plug it into your audio in your car, and you're going to need some power for the Raspberry Pi. So in my case, this plug here does not give me any power if the car is not running, if the engine is not running, so that's less than ideal. And this one gives me power as soon as I unlock the car. So basically what is going to happen if I power the Pi from this one, it will start booting as soon as I press the button on the remote, so I'm going to use that one. And of course, plug both plugs into the Pi. I cannot do this with one hand while recording, but anyways, it's pretty straightforward. And then you can place your Raspberry Pi wherever you want in your car. You can hide it, maybe do some little wire management or whatever you like. I mean, it's your car, right? Okay, I have switched to my secondary camera as I need to show you this phone. So first things first, I'm going to enable the hotspot via the hot button. So it says hotspot on. And now I'm going to unlock the car. And let's go to the... Let me just put away the key. Let's go to the car so I can show you what happens when I enter the car. There we go. There we go, and it says aux, and note the black island on my iPhone here. It will show you a cue when anything has connected to the hotspot. So basically the hotspot is running. But I suppose the there we go. So something has connected to the hotspot. This is a cue that the Raspberry Pi has booted successfully, and you can press play. This is playing on the phone now, and you can press this button here to switch to a car, and there we go. There we go, we have music in the car. So that's pretty much it for today's video, right? If you will want to copy paste all of the configuration files, I will be publishing them on my web page. So these things don't really fit well into the comment section below, so that's where I'm going to put it. So there you have it. I think this is a pretty neat and very light solution, very cheap as well. And I think it is going to solve my music problems in my car. As I said, I have been complicating a lot in how I want to make my music in the car function. I could use MP3 files or something like that, but often I have people with me that want to listen to some songs that I don't have, or similar scenario, or maybe podcasts and something like that. So all of this is a more practical way to have music in my car. Hopefully I have helped some of you with at least some ideas or maybe solutions if you also have an older car, as well as you can use this in your home. It does not have to be a car, just plug in an external speaker with an amplifier and you have a home boombox or something that is compatible with Spotify, right? Feel free to subscribe, like, and all these other things. And thank you very much to my long-term supporters on Ko-fi. It's Machine Gun, David S, Dragmine, and Mislav. Thank you very much, guys and girls, and I'm going to see you in the next video.